This is question number 11 from the final exam review. Letter A says, calculate the pressure in atmospheres exerted by 3 moles of nitrogen gas confined to a volume of 10 liters and 25 degrees Celsius. The first thing you want to do is organize your data. Pressure, volume, temperature, number of moles. So the pressure that they tell us that we want to know is unknown, and it's 3 moles of gas. And it's nitrogen gas, so I'll indicate that right here, confined to a volume of 10 liters at a temperature of 25 degrees Celsius, and don't forget to add 273 to that right away because you have to be in Kelvin. So the 25 plus 273 then would add up to 298 Kelvin. And this is the initial conditions that they tell us. They don't tell us any final conditions, and so we know right now that this is one where we don't know pressure, but we know 3 other variables: volume, temperature, and number of moles. And so we know it's going to be a PV equals nRT equation type problem solving situation where we're looking for pressure. Now if there were final information down here, then we'd know it'd be a P1 V1 over T1 equals P2 V2 over T2 equation. And so organizing your data can tell you what equation you're supposed to use. Solving this for pressure, pressure is equal to NERT divided by V. N right here is 3 moles. The R we want to use, it says we want it in atmospheres, so 0.08206 liters times atmospheres per mole times Kelvin, times the temperature, which is 298 K, divided by the volume, which is in liters, and make sure it's in liters so the liters cancel with liters, and that's 10. The moles cancel with the moles right here, the Kelvin with the Kelvin, and we're left with atmospheres as our final units, and so the pressure ends up being 7.336 atmospheres to 4 significant digits. That's letter A. Letter B says gas has a volume of, so now once again, pressure, volume, temperature, number of moles of gas, initial conditions, final conditions, organize your data. 250 milliliters at 70 degrees Celsius. Don't forget to add 273 to that right away, so then you get yourself into Kelvin. So this is 343 Kelvin. What volume does it occupy at negative 40 degrees Celsius? So we see that temperature changes from 70 to negative 40, and once again don't forget to add 273, and then we end up with 233 Kelvin right here. So this is our initial condition, this is our final condition, and then you have to get used to this in gas law problems. If they don't say anything about one of the variables, you're supposed to ignore it. So there's no change in pressure, and they don't tell us there's any change in number of moles. So now it's just a volume-temperature relationship, and you know the volume-temperature relationship is the television law. If one goes up, the other one goes up. If one goes down, the other one goes down. And so if we want to find the final volume, take our 250 milliliters, multiply it by a fraction that's going to make it get smaller, because you can see that the temperature gets smaller. Now your choices of fractions are 343 over 233 or 233 over 343. Which one would you choose to make it get smaller? Well, obviously the one with the smaller number on the top. Now, if you can't think like this, or you don't want to think like this, this is the same as a P1 V1 over T1 equals P2 V2 over T2 equation, where the pressures are canceled out. And now if you put the numbers in here, you're going to get this exact same equation, and you're going to get the Kelvin temperatures to cancel, and then you're going to multiply 250 times 233 divided by 343, and you get 169.8 milliliters. Notice the units just stay the same because they cancel right here. All right, the last one, letter C for number 11, says calculate the pressure exerted in atmospheres. So once again, pressure we don't know. Occupied by N number of moles is 0.375 moles of oxygen gas in a volume of 250 milliliters at a temperature of 40 degrees Celsius. Don't forget to add 273 to that to make sure that you get it into kelvins right away. Let's see. we're going to find out that this is our initial conditions, and there are no final conditions here. And so once again, we know that we're going to use P equals nRT divided by V, because there's no P1 V1 or T1 or P2 V2. There's just these conditions, and they're asking for this one right here. Alright, so this adds up to, I believe, 313 Kelvin right here. And so then putting in the numbers, we have 0.375 moles. Now it asks for the pressure in atmospheres again, so we'll use 0.08206 liters times atmospheres per mole times Kelvin, times the temperature, which is 313 Kelvin, divided by the volume, and this has to be in liters because you notice how this is in liters right here, so that would be 3 to the left, 1, 2, 3, so that would be 0.25 liters. The liters cancel with the liters, the moles with the moles, the Kelvin with the Kelvin. We end up with our answer in atmospheres, and that ends up being 38.53 ATM. That is number 11.